Well, thanks for joining us tonight, everyone. Today we are doing the first in a series of webinars that we are calling Data Literacy in the Wild. So this is exploring different data sets or exploring different topics through data sets. This one is the sports edition. I think it is really interesting to explore sports through data because they are just data producing machines with the number of repetitions that you have and the amount of sports that or the amount of data that are collected in sports. They produce a lot of data at the professional levels. Given what is at stake for professional sports, a lot of decisions are made using data, and the professional sports organizations are looking at those data very, very carefully when they are making decisions. So it all adds up to be a pretty cool real world example of how data can be used. As we go through these data sets, you're also going to be getting, in some sense, a demonstration of the data classroom tool, although that is not necessarily our main point as we show you these different data activities today. But given the size of the group that we have, feel free to jump in if you have a question. We would love to take your questions. If you drop it in the chat, we'll make sure to pause and get to your question and maybe even have a little bit of discussion around that. I guess I forgot to introduce ourselves. I'm Aaron Reedy. I'm one of the co-founders of Data Classroom. I'm a former high school biology teacher, a former researcher and biologist studying evolutionary ecology in a past life, but now I am the full-time CEO of Data Classroom. I would also like to introduce you to Blake Blaze, our Director of Operations. Blake is a former high school math teacher, as well as a former U.S. Naval Intelligence Officer, and he is currently an officer in the U.S. Naval Reserves. And what we're going to go through today, we're going to go through a couple things. The welcome and discussion is what we're doing right now. We're going to talk about a data set, this question of home field advantage and its analysis of wins and locations in World Cup soccer. We're going to talk about who is the data MVP, and this is an exploration of advanced player metrics in NBA basketball for the 2023 season, or for the season that has the regular season that has just come to a close as we moved into NBA playoffs. And then finally, if we have time, we can also touch on a data set called Do You Pay to Be a Winner, and exploring payroll data in Major League Baseball and looking for any statistical effects on wins and losses in those sports and success. We also, these three data sets, we have links to these data sets, and we can put these in the chat as we go. But when we send out the follow-up material for the webinar, we'll send the slides, and those links will be included. These are all freely available data sets that are on Data Classroom. World Cup soccer and NBA player metrics are still in development, so you'll find them in the list of data sets, but they are public. And then Major League Baseball payroll data is a tile in the resource library. It's been out for some time. So with that, I'm going to bounce it back to Blake, who's going to take us through World Cup soccer data set. And I see that Blake has dropped that into the chat there.
Yeah, I'll just say one of the fun things about using sports as a means of developing data science skills is that there's something kind of inherently similar about both sport and data science, where in sport you have these unequivocal outcomes. There are winners and losers, but there's also a story behind every contest. I feel like that's very similar when we talk about data science. We're working with numbers, but the whole point of developing data literacy and data science skills is to look at the context and to understand the story that the data are telling. And so with that in mind, we're taking a look now at a data set about World Cup goals scored by South American soccer teams in every World Cup that's been played since FIFA started using its current format in roughly the 1930s. Right now, we're in the table view of Data Classroom. This is where we have our data but laid out in what's called tidy data format, where each column is one variable. Each observation in a data set gets its distinct row. The important part about this arrangement is kind of first and foremost, it requires students to think in terms of variables, and that's really a necessity for setting up an effective experiment. And kind of secondarily, this is the way that modern data analysis programs and programming languages require your data to be structured. So you can see in this table view, we have the different variables that we're going to take a look at, and then as a feature of Data Classroom, a little flow chart across the top.
And Blake, could we just take a look at this table for a second? Would you go ahead and collapse the top view, and I just want to point out, just so we're all on the same page, each row in this data set is a different country's team for a single World Cup competition. Is that correct?
Yes, so you can kind of see going down here in the year column, it's the goals scored, goals per game, and then World Cup locations, a couple different ways to measure that location.
Mhm.
And then we have the teams Brazil, Argentina, and Uruguay. And I'll kind of explain the origin of this data set. For those of you who are familiar with Ted Lasso, there are the three fans in the pub who just kind of spit out these assertions about their team with such a certainty. I had a friend of mine who's a devoted soccer fan give one such assertion to me, and that was South American teams always struggle to score goals in Europe. And I was like, that's a really rich statement that we can definitely investigate with data. And so I took a look at the goal scoring success of Brazil, Uruguay, and Argentina because they've appeared most frequently in the World Cup. And kind of inexplicably, they've won 10 out of the 22 or so that have been hosted, which is a wildly disproportionate share for such a small group of countries. So I went to Wikipedia, looked up at how many goals each country had scored in each World Cup, put it into Data Classroom, and found a pretty cool story that it tells that I won't spoil it, but it seems like there may be some merit to my friend's assertion about South American teams struggling to score outside of South America.
And if you are unfamiliar with Data Classroom, there is also the assignment tab that looks like Blake was just about to click there. That will frame that sort of background story of why it's interesting, what data are collected that have bearing on the question. And you can see that in this student-facing document that's in the assignment tab. And I'll also point out that it's an embedded Google Doc. You can save a copy of the data set, and then you can edit it. And so you can change it in any way that you want before you share it with your students. So if you decide you see a way you can make it a better fit for your students, you have 100% freedom to do so. All right, let's get to the data, Blake. Let's take a look.
So in kind of approaching this question, the first thing I wanted to look at was kind of biggest picture first for just looking at goals scored. And so see, I add that. It's now going to appear in our control panel here. And these are the goals scored across all World Cups by all South American teams. And I want to see, is there any impact of the location where the games of the World Cup are being played? So I'm going to add next World Cup location by continent. And what's cool, right away, you can see that the biggest difference between any two mean of goals scored is between South America and Europe, which is kind of backing up exactly what my friend had said was the case. And what's, I think, great about making graphs and visualizations the first point of analysis is that these stories become clear in a way that they are not when you just look at all the data themselves. And so what I'm going to do next is actually zero in on just the comparison between South America and Europe. And to do so, I'm going to exclude the results from World Cups played in Africa, Asia, and North America, just for now at least. And what this will do is allow us to run a graph-driven t-test to see, is there a statistically significant difference between the goals scored by South American teams in South America and South American teams in Europe.
And Blake, before we turn to the stats here, wait. Let's pause for just a second. I have I think this is really interesting because so you're displaying these with the means and 95% confidence intervals around those, and you see a slight overlap in those, but that the difference in means is clearly, kind of, it's somewhat large, between there. And could you click on the values box for a second? I just want to see how large it is. Yeah, so 11.1 versus 7.26, like that seems pretty meaningful. But you can also see there's, quite a bit of variation around those, and some significant overlap between the two sets of data points too. Okay, we'll go. I don't want to hold you up. Let's take a look at the statistical analysis here.
And so we'll see data classroom kind of captures the work we've done already in isolating the variables as we have, where we have two instances of a categorical variable, right, the two locations against a numeric. And so it's telling us we've decided to do a t-test. I'll calculate it. We'll take a second to consider, all right, why did we use a t-test? How does it work? And now when we actually calculate it, I love this result because our p-value of 0.07 is exactly the kind of result that's going to challenge students to demonstrate that they understand what a p-value means, because it's not at 0.05 or lower, so we can't reject the null hypothesis out of hand. But it is low enough that we have to consider, oh, this has some meaning, even if it's not statistically significant by the rules that we typically establish in classroom settings. We can say there's some confidence that the groups are different, and especially if we consider the context of this. Like, if you were a professional data scientist publishing an academic paper about the impact of home field advantage on goal scoring, well, sure, you're not going to submit that it's a statistically significant difference. But if you're a fan of Argentina, these stakes really matter, and you're probably rooting for the next World Cup location to be held closer to home and probably not to be in Europe.
Yeah, it's also, it really can, I think, be helped to illustrate just, how conservative that 0.05 statistical significance cutoff can be, and how it is not, it is not a binary outcome. It's not just magic as you get below 0.05 that the data means something completely different than they did at 0.07. And this really, this is challenging for students at a lot of times in their math career. This is the first time when they're getting into data science that there's not such a clear right and wrong answer. I mean, the best thing you can say is that, given if in fact there is no difference in goals scored, right? There is no effect of South American teams playing a World Cup game in Europe, then you would only expect results that differ by this much, roughly 7% of the time. And so it very much is intriguing data. And I love that it doesn't definitively settle the argument one way or the other. If someone says, no, it's not statistically significant, there's no advantage to a South American team playing in South America. But again, like you said, if you are a fan and they're choosing, where the next World Cup is going to be held, you would certainly be hoping that it was on your home continent.
Yeah, and you could even fixate on, and I'm glad you brought up showing the values, that if the mean is 11.1 goals scored per World Cup in South America versus 7.2, that as a fan, as a casual fan in my case, that feels like a really big difference.
Absolutely, absolutely.
And I'm going to go ahead and expand the graph a little bit so we can see more of the control panel. While Aaron was kind of going more in depth about the importance of the p-value, I added a few variables to the control panel because I think what's great too is that we can explore other storylines. So if we wanted to look a little bit more in depth or consider goals scored in a different way, perhaps goals per game to eliminate the impact that just a deeper run in the World Cup would have, we can make that our y variable. And we see that the story looks to be somewhat similar, right? There's the overlap when we have the 95% confidence interval, but there's still a pretty big difference. 2.9 goals per game versus 1.6 goals per game.
And I think looking at it that way is really cool too, because it's it's showing that it's not, necessarily that total goals is not driven by just a few crazy outlier games where there was a high, high scoring games, but even when you look at it in this goals per game format, it's similar story.
And then just one kind of additional quirk, if you want to take a look at how this trend played out among the 3 different countries, we could add what we call a z variable, but really it's just overlaying a third variable on this 2-dimensional graphic here. and it will break out their performance by team. And so if we group them by Z, we can see if maybe there are even some trends within how each team plays. And the things that stand out to me, there's a really high variance for Uruguay. And then outside of the variance that is explained by this 1 point for Uruguay in 1930, it seems like Brazil tends to play either a style of soccer or has a talent that allows them to score more goals per game than their two peer countries from South America. All right, I'd like to pause for a second and see if there are any questions from the audience, any places you'd like to see this investigation go. Well, that was a quick look at investigating storylines in sports through data. I went back to my friend with this, and all he had to say back was "told you so." So all my hard work, I think was worth it. This was a fun one that your students could enjoy.
There is a question in the chat that is not necessarily a sports specific question, but an assignment based on an educational intervention. Will students be also prompted to calculate the Cohen's d to complement the p-value? We currently there is no output for Cohen's d or any other measure of effect size within Data Classroom. This is an area that is kind of under development for us, and we're thinking of adding. It's largely been prompted by the users of the university level version of our software, in particular psychology departments, where effect size is very, very important and very much a hot topic of discussion. So I would say you can expect some treatment of effect size beyond just looking at like the difference in means, but you can expect some treatment of effect size within Data Classroom that will come out in the next year, whether it's Cohen's d or some other measure of that. We plan to address that. Yeah, it's good, Chris. I see your comment that because students often believe the p-value is an effect size, and that is absolutely true. The sort of confusing highly significant with highly important or a massive effect, and the two are very, very different, where the effect size is largely this difference in means in the case of a t-test or an ANOVA type data, or it's it's your slope if it's a regression type data, but the p-value is determined, it's a combination of both the variance as well as the signal there.
And just one thing I wanted to demonstrate, let me take that off, while we were still here, was now that we've returned the observations from Africa, Asia, North America, we can see that when we go to running a graph-driven hypothesis test, there's going to be a different statistical test recommended, selected by Data Classroom because of the variables that we have shown. And part of why I bring this up too is I think any more thorough investigation of the home field advantage would include some look at the variation across all continents instead of just Europe and South America. But if there are no more questions about World Cup goals, Aaron, I'll turn it back over to you.
All right, so now we'll go and look at this NBA player metrics here, and let me get my screen up. And so this data set, first let me drop this into the chat for you before I share my screen. Bear with me here. Sorry, Blake, I should have had this ready right at the right moment, but here we go. Okay, so this is NBA player data, and here is the link. So that's in the chat, so we can all open up the same data set and look at it. And I'm going to share my screen here. and we'll take a look at these data. So these data are very recent. This is the 2023 regular season NBA. And it's all kind of tied to this question of, who is the best player? How do you evaluate the best player? And we're going to do that by looking at these some of these metrics that are used to evaluate players. Now, an interesting thing about the NBA metrics and the metrics that teams use to evaluate players is they're largely trade secrets. And so the actual player, the actual formulas that different teams are using and the statistical models they're using are proprietary, and they don't want to share those with people. And so for this assignment, I looked at, when I was making this, I looked at 538.com and looked at some of the metrics that they've used to try to recreate what they think is being used by these NBA teams. And they've developed this metric that they call, they colorfully call Raptor, and it stands for Robust Algorithm Using Player Tracking and On-Off Rating. So it's a little bit wonky there, a little bit nerdy. And it's basically an attempt to determine for every 100 possessions, how many additional points is a player worth by their offensive and defensive contributions to the game. And so positive ratings are good, and these are all plus or minus relative to this hypothetical average player. So if you are the average player in the NBA, you have a Raptor rating of 0 on both offense and on defense. You neither cause your team to score more or less than they would have otherwise. I've included links to all of the fine print on the 538 website. So if you have a student that thinks that's really cool and really wants to dive into the methodology, they can do that at 538. It's one of my favorite sports websites. They cover sports, science, and politics through the lens of statistics. So if you're not familiar with them, I think they're a really cool website, and they're the ultimate source of this data. And then we downloaded this data, which included 826 rows of data, and it contained rows for each player, and then a second row for each player that played in the playoffs so far. And so this data set is getting updated in real time every night as the playoffs go on. But I subsetted the data, and I just took regular season data only, and then I only included players who played more than 500 total minutes in games during the regular season, and that weeded it down, or narrowed it down, to 381 players who had played more than 500 total minutes in the game. And then we'll do this while looking at the table here. The variables in here, we have the player's name, the team name, or this three-letter code for their team, playing time in minutes, and then their Raptor offensive rating, Raptor defensive rating, their total Raptor rating, and then this wins against replacement, which is another metric, not looking at how many points better than the average player or worse than the average player someone is, but how many wins they're responsible for better than an average player, over the course of an NBA season. And so with that, we'll get into the data. And the first thing that we have students do in this is plot all the offensive player rankings and spend a little time looking at these. Each dot is a different player, and hovering on these different dots to see who are the outliers in the data set. So who are according to this Raptor rating, the strongest player in the NBA is Nikola Jokic from the Denver Nuggets. Damian Lillard from Portland Trailblazers is the second. As I move down, Luka with the Dallas Mavericks, and so I can see where each of these players rank, and I can hover on any data point in the field to see what a player's Raptor offense rating is, and we can see who is poor Blake Wesley, statistically the worst offensive player in the NBA. I'm sure he's still quite a handful in a pickup game, though. We through this, then we also will explore this in defense, and we'll do this just one variable at a time for a second. So I'm going to place just defense on here again as a single variable, and we can look and we can see that Alex Caruso of the Chicago Bulls is statistically the best defensive player in the NBA, followed by Blake Griffin of the Boston Celtics. That one was kind of a surprise to me. But you can kind of see Brook Lopez, no surprise there, he was in the running for Defensive Player of the Year. And so you can kind of Anthony Davis, you can kind of see where these players fall. And it's really interesting to the next thing we'll do is build this plot of looking at offense and defense on this XY coordinate plane. And then looking at really who are the outliers, and with this you can start breaking down, with students, what does it mean if you're a data point way over here, right? Or what does it mean if you're a data point way over here? And so you can kind of think of this in terms of quadrants, where up here in the upper right, these are players that are both very strong on offense and defense. Players in the lower left are relatively not strong on either. Players in the bottom right, strong offense, weak on defense, and players in the upper left, strong defense, weak on offense. And you can also overlay some other variables on here. I'm just going to overlay Raptor total. So this is just their combination of their defensive and offensive variables, and I'm going to add this as Z to give this color code, so we can take a look at who are the strongest overall players. Those statistically the strongest are the ones that have that dark red. Who are the weakest? That's the dark blues and the black there. And so we can see this player who's this outlier way up here. This is Jokic from the Denver Nuggets, just way out there with a total Raptor score of 14.1, just way higher. The controversy here comes in when you look at this number 2, Joel Embiid from the Philadelphia 76ers, and I have to tread lightly here because we have a Sixers fan in the room, but at 8.22 here he's the second highest total Raptor rating. But this actually, I think, invites a lot of really rich discussion, and some of the later questions in the activity are talking about, well, not every decision is made purely by data. And so what other things could contribute to this? What other things were considered by MVP voters? So students will first go through this and pick, who is the top 5 in the league statistically in this measure of total Raptor. But then they'll add there, I'll click over to the assignment tab for a second, and you can see that we've got a table included in here which shows the actual MVP voting that took place this year. And so we can see here was the actual MVP voting: Embiid first, Jokic second, Giannis third, Jason Tatum fourth, SGA in third. In fifth. And then they can compare those to what the statistics say. And then that last question in the activity invites them to kind of pick apart what other, or consider what other factors go into something like MVP voting. What other factors besides statistics are in there. And I'll build that back again, because I want to look at some other storylines as well in here. So build that. So we're kind of looking at this. There's a couple other storylines in here that students can explore, and it's kind of some auxiliary questions that some of them had surprising results. And so one question that I immediately wanted to think about, are the better players on offense also the better players on defense? So in other words, if you're a better player, are you better at both ends of the floor? Are you good on offense and good on defense? And you can kind of see from the shape of this cloud that there's not a really strong relationship between a player's offensive results and defensive results. If we can add a regression line to this, and you can see that even, just looking at the trend, it's barely an upward trend. It's got a slope of 0.04 on there, and it's got an R squared value of 0.003. And so, mathematically thinking about this is a player's offensive Raptor rating only explains far less than 1% of the variance in defensive Raptor rating. So they're not tightly correlated at all. If you want to run the statistical test for this, which I don't think is strictly necessary, but if we look at the linear regression here and we calculate this, we get a p-value of 0.26. So we're not, we'd expect just, this is 1/4 of the time we're going to get a cloud of data that has this kind of a relationship between offense and defense, if it's just completely random. And so that, this is really, I kind of think falls into the little to no evidence that a player's offensive rating affects their defensive rating.
Aaron, this might be the way the activity goes anyways, but is it possible to take a look at whether defensive aptitude or offensive aptitude has a greater impact on playing time?
It is, and that's actually not one that I've looked at. So let's take a look at that. So we could think about that. The kind of, first thing I'm thinking about off the top of my head is I'll put playing time as a response variable, and I'll put, offense as a predictor, and then we'll switch it over and put defense of a predictor. And I guess if the slope is steeper, then it's, more of a factor in playing time. So let's take a look at that and see. So I'm going to put playing time on Y. I'm going to drop the wins against replacement and just look at that. That's interesting. So there's definitely, a fairly steep slope there. For every 1 unit increase in the Raptor offense, there's 114 unit increase in 114 minute increase in playing time. So this is interesting, and I guess it's hard by itself to to say what it means, but let's look at it and compare it to the defense. If I flip and I look at defense, yeah, that's a very different slope. So together, I think that looks like pretty strong evidence that offense affects playing time more than defense does in today's NBA.
From personal experience, as someone who's a defensive specialist in high school who didn't play very much, this feels true to me after seeing this played out.
Yeah, apparently coaches are thinking of it in this way. One analysis that I did, I'm just going to go back and just see those. Yeah, those. So slope of 114 for the relationship with offense, and a slope of 22.6 for the relationship with defense. So it's quite a bit different. One question I did wonder about when I got this data set in front of me was just, how much more playing time do better players get than weaker players? And so I wanted to look at like the Raptor total score as my predictor, and playing time as my response variable there. And so I looked at it this way, but I didn't before think to break it out by offense and defensive separately. I also looked at this with wins against replacement. So I'm going to change that Raptor total metric and look at wins against replacement on there. And it's largely the same story, that your stronger players play more, but there is still a lot of variation on there as well.
And I guess Jokic might explain most of this shape as the outlier way to the right there, but it almost makes sense that this looks like there might be a logarithmic curve to it, where there's a cap on how many minutes even the best players can play. So there would kind of naturally be a an upward limit on that.
Yeah, that is totally true. And I just want to see, what that, oh, we can't use a logarithmic because
Okay,
we've
because of the
got
war.
negative values in there, but if we did a transform, we could probably just kind of approximate a curve and, look at a quadratic where you can see it definitely has a, quite a hook to it as you get to the top. But yeah, I bet if you do a data transformation, that logarithmic would be a good fit for it.
Yeah, I thank you for indulging these questions as I see this for the first time. Uh, it's just cool that you can do this type of analysis by iterating quickly through different graph types.
I I also thought it was really interesting to look at these like Raptor totals, which are a measure of how good a player is, um, to look at like team on X and Raptor total on Y. And this is a really messy graph because you have so many teams. But one thing I did with this, I added descriptive statistics and then I hid the dots, so I could look at these teams. I could even go into the appearance menu and change y-axis to just go, we'll just have it go from -5 to 5. I think this is a pretty cool way to look at the data and just look at the kind of variation from the lowest ranking teams in the league to the highest. And there are some surprises too. Denver, who's done quite well in the playoffs, is not among the highest, but Boston is, and they're currently, the statistical models favor them to win the title. So, okay, well, with that, did we have any questions coming in there?
No questions in the chat yet specific to what you demonstrated, other than my observation that I was happy that there was a Blake at both extremes.
Yeah. Cool. Okay. Well, then I guess the next data set, and I'll just close out of this. And again, you've got the link to this data set in the chat. If you want to play with it on your own, you can do that. I'm going to open the resource library, and I've already searched for this. Do you have to pay to be a winner? This baseball team payroll data and payroll and performance data. So I'm going to open this. Blake, this is one that you worked on for us when you first started with us years ago.
Yes, almost exactly 3 years ago.
Do you want to give an introduction to these data?
Sure. So the small backstory was I was in the Navy at the time and looking to join Data Classroom, and Aaron wanted to see if I had any statistical aptitude to me, I guess. So my first assignment was to come up with a ready to teach. And I had kind of like always wondered, is there a relationship between a team's payroll in Major League Baseball and their success? And Major League Baseball is kind of unique among the professional sports teams in North America because there's a much less strict salary cap and not even really a hard cap the way there is in other sports. You have wild variations in the amount that teams spend on their teams, on their players. And so wanted to break it down. I went and found the payrolls for the average team going back, I forget how many years, the average team in the regular season, average payroll for teams in the playoffs, and then the average, or just the payroll for the team that won the World Series, and then kind of broke it down and found some interesting results.
Yeah, so I was trying to give a visual aid to what you were saying and thinking about the variance in payroll. This is in millions of dollars, and you can see the mean payroll for a Major League Baseball team is 88.2 million, but there is quite a bit of variation on that, with the 3 teams in the data set having payrolls of less than 20 million there, and a couple of teams I guess 3 teams in the data set having payrolls of greater than 180 million. So quite a bit of variation here. So I guess your kind of central question here, I'm going to go back to dot plots, and we're going to break out this payroll data by the different success levels. And this was different categories. And we had, what the payroll was for the average team, what the payroll was for the average playoff team, and then, what the average payroll was of a World Series team. And this I think is a good data set to kind of talk about how, data science isn't strictly math. It does require some sort of, domain knowledge. It requires asking careful questions. And so, one thing you might think about with this data set, Blake, how many years did this data set span? Do you remember?
I forget how far it goes back. To be honest, I had to go back to the table view, but it does have some interesting context questions with it. Like there was a year, I think it was, um, I'm not quite old enough to remember this, but it was 1994 when there was a strike shortened season. So there was no uh, payroll number for the playoffs or World Series that year.
Yeah, it looks like it goes 1990 to 2019. And so one thing that is going to play a factor in looking at these differences between these three levels of success is also adjusting for inflation. And so what Blake did here is he created a new variable where this is payroll in 2019 dollars, which is when we put this activity out. And so right now I'm looking at just, the raw dollars, but if I put the payroll in 2019 dollars, this is more of an apples to apples comparison here in looking at the data. And there is, a strongly suggestive pattern in here where you see these three groups are the average increases in the stepwise manner, where, the very best teams are teams that make it to the World Series. They also have the highest average payroll, $126 million on average. Playoff teams, a slightly lower level of success, an average payroll of 11.7 million. And then average teams, a payroll of 93.5 million there. You can run a statistical test on this if you wanted to run the ANOVA and see if these groups differ statistically across categories. You can do that. And when we run that ANOVA, it's telling us, hey, we're running the ANOVA because we're looking for a difference in means across groups, and we have more than three groups. What we get here is a very low p-value of 0.01, meaning a very strong confidence that success level, does predict payroll to some degree, even though there's a lot of variance. Getting that nice stepwise pattern contributes to that statistical significance as well.
And Aaron, what I might suggest in absence of questions from the chat is, with the time we have remaining, we could go through an interactive analysis for a t-test with this data set too.
Okay, yeah, sure. We can do that. If you wanted to have your students dig into the math behind a statistical test, they can do that with our interactive analysis, which is another vehicle for statistical testing. And we only have interactive analysis available for t-test, chi-square goodness of fit, as well as the linear regression. But we can look at this data and maybe let's look at the starkest difference, or what do you think? Would you which we could do the starkest difference, or we could do the smallest difference? What 2-point comparison should we focus on here?
Let's just do playoff team and World Series. Like, we need to spend more to get over the hump.
Okay.
And what's cool too is if you just go straight to table view from here, the checklist will prompt us to fix the data.
Yep. Okay. So I'm gonna save this this version here, and I'm gonna go over to table, and let's take a look. So you can see this flow chart at the top guides students through working with their own data, importing data, preparing data, graphing it, and then on to statistics. And we went up to graph-driven test already, but we'll go through this interactive analysis, and we'll select actually, what I need to do first, Blake, is I need to exclude the average teams, because we're only interested in doing this comparison. So to do that, just if I did that a bit quickly, I click next to any categorical variable, you'll see this little button that says values, and it allows you to do things like custom colors or custom symbols for each category, but it also allows you to exclude. There's also a filter over here on the right of the data set, but I'm just doing it by excluding. So this is where the filter is if you're looking for that. And then I'm going to go ahead and go into the interactive analysis, and I'm going to select my variables here. I'm going to select success level as an independent variable, and I'm going to select payroll as a dependent variable. And this is maybe a little bit counterintuitive because we probably do think it is payroll that is affecting success level rather than the other way around. But mathematically, this is a more straightforward way to do this comparison. So choosing those variables, we've also got data in the dependent variable column that is inconsistent. So I just want to look at what that is in that payroll. We've just got a couple of missing data points. So, or we've got, those two, and I'm just going to exclude those and go back in. And then I'm going to select the t-test where it asks me to select that. And then the last thing I need to do is I just need to save my changes because we excluded some data points. And so what this does is it's going to produce a document. And so we have to have some the file saved before we do it. So now we've gone through this checklist. This is a more step-by-step of why you're doing a t-test rather than graph-driven test, which just kind of spits it out. And we're going to give this an analysis a title, and we'll call it, difference in payroll between playoffs and, World Series. And the research question, it's suggesting this research question based on what we chose as the variables. And so now when we run this analysis, we're going to go through this, and this is very much the way that my stats teacher in grad school would walk us through data sets. And the first three things we're going to do is make some visual estimates. And it's not necessarily important that the student is 100% correct on this, but we want them to start building up this ability of sizing up data with their eyes. And so they grab the slider and just say, hey, do you think these groups are different? Do you think these data look like they have different distributions? And there is no right or wrong answer here. They just can slide this to wherever they think it belongs, and then they're going to get feedback as they actually calculate this. So I'm just going to drop it here at some indication the groups might be different. And when I click done, it logs this into my lab notebook. And the next two things we're going to do is estimate where we think the mean is and how much variation is around that mean. So, maybe the mean for a playoff team is somewhere around here. And maybe I think the mean for a World Series team is somewhere around here. And again, I get those logged. And now when I click calculate, computer is going to visually show the student, where those means are. They're a little bit closer than I estimated them to be, but I was in the right ballpark. This step tends to be a confidence builder for students too. Most people are pretty good at sort of picking out where the mean is in a cloud of data points. And then the next thing is to estimate, plus or minus one standard deviation. And the text coaches them to grab the shaded area, cover 2/3 of the data points. So maybe that's 2/3, and maybe that's 2/3. And then again, the computer will calculate that and show that where, show the variation. My estimates, again, while not spot on, they're in the right ballpark. And I think most students will quickly learn how to do that as well. And so now if we're actually calculating the test statistic, we're going to go on, do the t-test and see, is there a significant difference between these? We're going to first measure the difference between means. And this is the signal that drives this test. And so we can see that, $13.9 million is the difference between these two groups. And then we can measure the variation, and we're calculating this quantity that's called group variance. And the important thing I think for a novice to know is that this is coming from the spread around the means. If you have a greater spread of points around the means, you have greater group variance. And then when we calculate the t-score, it is a ratio of these, and it's balancing them. If they were exactly equal, it would be 1.0. And so this is pretty close to flat. And you can kind of see that with your eyes looking at the scale, that mean and variance are really balancing themselves. When we count up sample size, these are the inputs that go into calculating the p-value. We can also expand this to look at how the area under the curve affects p-value, and this is sort of making the sort of what is implicit in those old school tables a little bit explicit. And I slid this t value over here to a point where 95% of the area of the blue area is under the curve is here, and then the tails have an additional 5%. So this indicates that somewhere with this many samples, you're going to get significant result here when t equals 2. Okay, and remember t was 1.3 in this case. So when we calculate the p-value, we see that those things are going inputs in, and we get a p-value of 0.21. So there's no statistically significant difference between these two teams. And we'd expect a difference this large at random, roughly 21% of the time, indicating that that difference we saw in the ANOVA, where we were looking at all three groups, average teams, playoff teams, World Series teams, it's not driven by this difference in between playoff team and World Series team alone. And the idea with this is a very, very different way to approach a statistical test. This is an approach you might use if the math behind the t-test was very important for your students. If it wasn't, if you're just wanting to look at a graph, look at results, I would recommend using what we were showing you earlier. If you want to dig into the math more, this would be a different approach you could take.
Yeah, also I love the interactive analysis because it brings the formula to life in a way that most statistical tests, the way that it's taught, do not. Like getting to see the way that group variance impacts the test statistic, I think is really important for students. So it's not just a really abstract, kind of obscure means of arriving at an answer.
Yeah. Well, cool. Well, with that, we have another question there. no Satterthwaite tests, no or Welch and degrees. We don't have a Welch test in there. Degrees of freedom are added, or at least the sample size is added up. And if you look in the report that is generated, this lab notebook, which by the way, you can download this, and it's a document that your students can open up in Google. They can open it up in Word. But this lab notebook does contain degrees of freedom in there. They're listed right here, and it also explains its sample size -2 in this case. I like that we've got some statistics aficionados in the audience, or at least I'm estimating that based on the questions that we have here today. Yeah, so with that, maybe we will wrap up the recording, and for anyone who's watching the recorded version, I'll say, thanks for joining us, thanks for watching. And with that,